Hello, I'm Omin-jae, number 15, in class in 2nd grade. From now on, I will start presenting English topics. First, the table of contents will introduce the first boundary and the FinFET process, which is one of second boundary process. Lastly, I will end by presenting the GA course and enhanced version of FinFET. What is a boundary? Yes. Many people will think it's a difficult term to answer. Then what is semiconductor? Let me change the question. I would say the semiconductor are in the middle of conductor and non-conductor. The reason why I ask this question is that foundry is deeply related to semiconductor. Foundry is a company that manufactures semiconductors. Foundries is to produce many semiconductor chips on the top of silence wafers in a limited space and to create semiconductors with better performance and power efficiency. The basic of foundry is MOSFET. Metal oxide semiconductor field effect transistor is abbreviated to MOSFET. Many presenting call the MOSFET and say it is a metal oxide semiconductor field effect transistor. MOSFET is the most commonly transistor structure in modern times, and the limited MOS transistor in a frame form has a structure in which the gates and channel meet in a plane. However, if the size of such a planar transistor increases, the distance between the source and the drain becomes better. But on the other hand, the smaller the size, the closer the source and drain areas, the worse the semiconductor device characters are. The inference process is the FinFET structure. The reason why this is called a FinFET structure is the resemble of FishFET. Transistors are the main elements that make a semiconductor, which can be amplified or switched by controlling the flow current. Gate is an important part of the transistor rules. If we apply a voltage to gate the transistor, the current flow and vice versa, the current will be cut off. And when applied to semiconductors, the transistor becomes more efficiently as the voltage is applied to gate. The current flows between the source and drain, and the wider contact between the gate and the channel. Also, the shape of the three-dimensional structure of the FinFET forms a three-dimensional structure with a flat contact area and stacked up. Starting is to a three-dimensional level can lower the operating voltage to address the limitation of the MOSFET. And there are a total of the two pictures on the screen. First, the picture on the left shows the two dimensions of MOSFET, and the picture on the right shows three dimensions of FinFET. There is a different picture from this picture, which shows at a glance the previous mentioned contact area state of work to form a three-dimensional shape is a transistor with flat contact area, which increases performance. There are MOSFET models and FinFET models in the following three culture. Area which showed the stacking of its higher contact areas, and this time we present a picture to see how high the contact area is when stacking up through 3D. Looking at the total of four features, we can realize the FinFET process is more efficiently than MOSFET process. The GA process, the rare versions of the Raspberry Foundry, the GA process is called gate or ground. And the people call it the next generation transistor structure that has evolved from the FinFET on the next level. The reason for the development of the GA process is the MOSFET's improved FinFET process refinement has also been enhanced. And a new next generation process has been developed due to the limitation of FinFET process. In addition to GA process, MVC effect, multiprise cancer field effect transistors is under development in Korea. The GA process we will introduce ultra-fine characters with 3 nanometers and 3 transistor. We will use the next generation semiconductors to require higher performance and power success and artificial intelligence, big data, self-driving, and the Internet of Things. Next, this is a picture of the GA process. The main reason for the development of the GA process is efficiency in FinFET process. The gate surrounds 3 sides of the channel. To be more efficient than the FinFET process, the interface between the gate and the channel must be wider. This allows more control over the flow of current by wrapping a flow size of the channel. Let's look at 2 and 3 dimensions of MOSFET, FinFET and GA to see the difference points and advantages. First, if you look at the 3 process in 2 dimensions, you can integrate see the development of the gate and channel contact and the more inspective. The larger the content area, the better the performance. And the contact is this. And similarly, if you look at the 3-dimensional process, you can realize that the content is extended, including the 2-dimensional image of the gate, the channel touching each other. Or 3 process seem easy worse, but they are difficult to realize. However, Foundry is desperate trying to make up what has not been implemented come here. This is the end of the presentation. Thank you.